Okay, we're going to take some time today and review over a lot of our material as we approach the Unit 3 test. We're going to go through several problems similar to those that you'll be seeing on the test that's upcoming. Thought I'd take a few moments here and go through them with you in this video format. Let's start off taking a look at the complex numbers that we've been working with. The instructions here say simplify, which mean to carry out the operation that's there and put together whatever we can. For number one, we have an addition problem. We're going to add the two complex numbers there, -3 plus 4i plus -5 minus 2i. And this setup, really all we need to be aware of is that i's go with i's and constants go with constants. So it's basically like collecting like terms. So we'll take the -3 and the -5 and we will combine those and we will get -8. In addition to that, we're now going to take the 4i, the positive 4i and the -2i and combine those. Well, positive 4i and -2i will make 2i. So what we finish off with, there's nothing else we can really do in this problem. We combine the terms that we can combine. -8 and 2i don't go together. So our final answer is -8 plus 2i. And it's that simple when we're adding complex numbers. Now, in number two, we have a very similar problem. In fact, we have the same two complex numbers, but in this case, we're being asked to multiply, which we know because there's no symbol in here between the two, so we're going to multiply these two complex numbers. Well, we would just do that following our normal procedure for multiplying binomials, which is sometimes called the FOIL method. We would take -3 times 5, and that's going to be -15. -3 times -2i becomes positive 6i. And again, we're just treating the I at this time like it's just a regular variable. Our next step would be to take 4i times 5. Positive 4i times 5 is plus 20i. And then we would take 4i times -2i, and that is going to be -8i squared. Now you'll remember that we've also talked about some things here, but the first thing that we want to recognize is that we have an I squared in the problem. Well, an I squared, if you'll remember, is equal to -1, and we will talk a little bit more about this when we get to the next problem actually, but that's going to have an effect on this problem, on this term, because it becomes -8 times -1. Well, -8 times -1 is actually going to just make this a plus 8. So instead of having -8i squared there, we're going to just treat that as it's a plus 8 as we begin to collect like terms. So as we collect our like terms, we have -15 and positive 8. That makes positive 23. Excuse me, that is incorrect. It makes -7. -15 plus 8. And then we have a positive 6i and positive 20i. Those are going to go together and they make positive 26i. So that is the answer that we get. Ironically, we don't have a squared or anything there like we do a lot of times when we get a binomial. We don't have a squared variable. And that's all due to the fact that the I squared, again, changes to -1. So we'll make that adjustment anytime we have an I squared in a problem and we're simplifying. Now, number three, when we look off, initially it looks like it might be already simplified. However, we've talked about the powers of I and the fact that I squared we'll just treat as a regular I, or excuse me, I to the first we treat as regular I to the second, or I squared, we call -1. And if you remember, I to the third is -I, and I to the fourth is actually equal to 1. Now, We did a whole explanation of that in class. I'm not going to go through that here in the review. If you have some questions about how that happens, please feel free to ask me. But we go through these, and we've learned that once we get through the fourth power, it becomes a repetitive cycle. I to the fifth is I to the sixth would just carry off at -1, I to the seventh would be negative I, and I to the eighth actually would carry to 1. So all we have to do to find out what I to the 30th would be is we could real simply count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30 would actually be right here. I don't want to put that as a negative, but 30 would put us at I squared. Basically, you can count through and get to the 30th one, and that would put you where you are. So I to the 30th is equal to -1 as well. I to the 31st would be negative I to the 32nd would be 1, and so on. It just carries on. So with this in mind, we're going to say that that's -4 times I to the 30th, and that becomes -4 times -1. Well, what is that? -4 times -1 is actually +4, and that is what -4 I to the 30th simplifies to be. Now our last one here on the screen is a division problem, and it's basically in the form of a fraction, and we've determined that we don't need to leave an I in the bottom of a fraction at any time. It's just like leaving a radical in the bottom of a fraction. We don't do it. So what we should do at this point is multiply the conjugate of the bottom term, or the denominator, to both the top and the bottom, and observe what happens. Well, the conjugate of 1 plus 2i is 1 minus 2i. So we'll take 1 minus 2i, and we will multiply that to the top and the bottom of the fraction. And in this case, we're going to use the FOIL method, just like we did before. We have 1 times 1, so that's 1, of course. 1 times minus 2i would be minus 2i. 3i times 1 would be plus 3i. 3i times -2i is going to be -6i squared, and we'll address that in just a second. Continuing on the bottom, you've got 1 times 1, which is 1. 1 times -2i, which is -2i. And then you've got 2i times 1, positive, so that would be positive 2i. And 2i times -2i, which would be -4i squared. Now again, like we said, the I squared is going to change to -1. So this -6i squared actually becomes plus 6. And on the bottom here, -4i squared becomes plus 4. And that's basically what that I squared change into -1 does. It changes the sign of that term, and the I disappears. So what we have when we collect our like terms is we have 1 and 6 go together to make 7 on the top, and then -2i and 3i make I, or 1i. And on the bottom, the -2i and the positive 2i will actually cancel each other out, and they're gone. So we have 1 plus 4, which becomes 5, and we finish this out with 7 plus I over 5. And that is what we get simplified out of that fraction. Very simple once we figure out the fact that all we have to do is multiply the conjugate to the top and the bottom. And again, I'll repeat, the conjugate is the same complex number with just a different sign in the middle. So if we had 1 plus 2i, the conjugate of that would be 1 minus 2i. If we had 2 minus 5i, the conjugate of that would be 2 plus 5i. We would just change the sign. All right, let's look at a couple other problems. Here's another type of problem that we looked at in this unit. A system of equations involving a quadratic and a linear function. In this case, we've got them both equal to y. Y equals x squared plus 10x plus 4, and y is equal to 3x minus 6. And we're going to try and identify the x and the y that both, or any x and y coordinates that will work for both of these equations. To do so, what we're going to start off is, we'll start off by setting these two equal to each other, since they are both equal to y. They have to be equal to each other in order for that to happen. So we get this, and we'll now follow the steps of solving this quadratic equation to identify some values of x that will work here. The way we do that, of course, is we get everything over on one side. So I'll subtract the 3x. I will add 6. And what we finish here with is x squared plus 7x plus 10 is equal to 0. And hopefully at this point you're becoming familiar enough or comfortable enough with solving a quadratic that we will understand that we just factor this out. We look for the factors of 10 that will add to make 7. And of course that's going to be 2 and 5. To get positive 7, we'll say x plus 2 and x plus 5 equals 0. So that means that x is equal to negative 2 or negative 5. Well, those are just the x coordinates. We have to find y coordinates that go along with these. So what we're going to do is take those values and plug them in to one of the equations. I'm taking y equals 3x minus 6 because it's the simpler of the two. You can plug it into the other one if you like. But if x is equal to negative 2, we plug that in and we get y is equal to 3 times negative 2 minus 6. Well, 3 times negative 2 minus 6 is negative 6 minus 6, so that's y is negative 12. So that gives us 1 point, negative 2, negative 12. Well, we also have another value of x to try, and that is negative 5. So we'll take that one and plug it into the same equation. Y is equal to 3 times negative 5 minus 6. So that's negative 15 minus 6, which would be negative 21. So you get a second value for y that goes with your second value for x. So our second set of coordinates would be negative 5, negative 21. These are the two solutions to our system of equations. And if we graphed out the parabola for the y equals x squared plus 10x plus 4, and the line that went with 3x minus 6, those two would intersect at those 2 points, negative 2, negative 12, and negative 5, negative 21. Okay, let's now look at another type of problem where we're actually graphing the parabola out based on the properties of it that we can get from looking at the function. The first thing we're going to want to do is, whenever we look at a function like this, we want to identify what a is, and we'll get a from the coefficient of the quadratic term. In this case, that's 2. We get b as the coefficient of the linear term, and in this case, that's 8, and c is our constant term, which is 7. So we're going to use these 3 pieces of information to identify our direction of opening, the equation of our axis of symmetry, the vertex, and the maximum value of the function. We'll also use all of that put together to graph the actual function once we get all of it. So let's jump in. We'll start off by finding the direction of opening, which is part A. To find the direction of opening, all we need to do is look at the a value. If a is positive, our parabola is opened upward. If a is negative, it's opened downward. Well, here we can see that a is positive 2, so we know that our parabola is going to be opened upward because of that. So that's part A. Simple as that. Part B, we're going to find our axis of symmetry. To find our axis of symmetry, we need to put it in the form of an equation, and that is going to be x equals negative b over 2a. And this is some information that we actually use to find the vertex as well, but we start off by finding the axis of symmetry. Negative b, in this case, b is 8, so that would be negative 8 over 2 times a, and a is 2 also, so that's negative 8 over 2 times 2. Well, that's negative 8 over 4, which becomes negative 2. So our axis is x is equal to negative 2. And that'll come into play as we begin to graph here in just a moment. For part C, we have to find our vertex, and we've already identified the x-coordinate of our vertex is negative 2, and we found the axis of symmetry. So now we just need to find the y-coordinate that goes in with it, and we do that by taking the x value that we found and plugging it into the function. So we've got 2 times negative 2 squared plus 8 times negative 2 plus 7. And then we begin to work that out. Well, negative 2 squared is 4. 2 times that becomes 8. 8 times negative 2 here is going to be minus 16. And then plus 7 gives us 8 minus 16 plus 7. Well, that's negative 8 plus 7 would be negative 1. And that tells us real quickly that our vertex is negative 2, negative 1. So there's our third piece of information. And we're going to use this when we make our graph here in just a moment. Part D is asking us to identify the max or min value. Well, that is your y-coordinate. And in this case, our parabola is going upward. Our y-coordinate of the vertex is at the bottom of that value, so we must have a minimum when our vertex or when our parabola is going up and our vertex is at the bottom. So our minimum value in this case is going to be equal to what we get from the y-coordinate, and that's negative 1. So we found our direction of opening, which was up. We found our axis of symmetry, which is x equals negative 2. We found our vertex to be negative 2, negative 1. And we have identified that our minimum value for this function is negative 1. All right, quickly now we're going to graph this function based on that information. So we're going to plot our vertex, which is at negative 2, negative 1 on your graph. That would be right there. And we know one other piece of information is our y-intercept, which is 7 in this case, and we get that from our c value. Well, we can plot a point up at the y-intercept being 7, and that tells us that we have a point right here. And if you remember, I talked about the axis of symmetry being x equals negative 2, so that's an imaginary line, not actually part of the parabola, but it's an imaginary line that passes through that area where x is negative 2. Well, if we reflect the y-intercept of 7 onto the other side of that, we would have a point there. So now we have 3 points, and it's not going to necessarily give us a perfect graph, but it gives us everything that we would need to know to make a rough sketch of what this parabola is going to look like. And let's see if I can do it here on the snortboard. So we get something that looks kind of like that. And again, this is a rough sketch, which is all we're going to be responsible for at this point. But that is what our parabola looks like, that part in green. And we've used A, B, C in order to find those points enough to make the parabola. The last problem we're going to look at right here is solving a quadratic inequality using algebraic techniques. When we have an inequality, remember that you have a wide set of numbers that end up being the solution. What we're going to try and do with this problem is narrow down a solution set based on that. So we'll start off by treating this as an equation, and we'll just try to start working with the equation 2x squared minus 5x minus 3 equals 4. And we'll solve this by first off getting the 4 over to the other side, so we'll subtract it over, and that gives us 2x squared minus 5x minus 7 equals 0. So we have to solve this equation, and first off, we're going to have to factor it. So we will identify the product of 2 and negative 7 would be negative 14. We can put x squared with it, and we have to find the factors of negative 14 that will combine to make negative 5 here in the middle. So our factors of negative 14 would be 1x and 14x, 2x and 7x, and I believe that's it. So does one of those pairs subtract or combine to make negative 5? And the answer is yes. We can combine positive 2 and negative 7, and they would make a negative 5x. So that's what we're going to use as we begin to solve this. So we've got 2x squared, and then I'll put in plus 2x and minus 7x, and then we're going to put in minus 7, and then we'll begin to group. I'll cover up my minus sign there, hopefully you know that's there. And we begin to take things out. Well, out of this first set of parentheses, we can take out a 2x. That would leave us with x plus 1. In the next set of parentheses, we will take out a negative 7, and that would leave us with x plus 1 as well. So our factors are x plus 1 and 2x minus 7. And this tells us that x is equal to negative 1 or 7 over 2. So we're going to take that negative 1 and 7 over 2 and look at them on a number line real quickly. And I'm not going to be very specific, but negative 7 over 2, or excuse me, negative 1 would be somewhere back here. 0 is over here. And you got a few points here, and there's 7 over 2 as an estimate. And we say that these two values cut all of the numbers into 3 sections. You have a section back here, a section here, and a section here, which we're going to test values in to see which of those work. Well, real quickly, let's go through and pick a value in this section where we're less than negative 1. And I will try x equals negative 2, and I'm going to plug that into this inequality to see if I get something that's true. So that's 2 times negative 2 squared minus 5 times negative 2 minus 3. And we want to see if that is less than 4. Well, this is 2 times 4, which is 8. Negative 5 times negative 2 would be plus 10 minus 3. Well, that's 18 minus 3, and that is not less than 4. So we know that this section does not work. We'll try a number in this section now in the middle, and I'm going to choose 0 because that's a quick one. And that'll be 2 times 0 squared minus 5 times 0 minus 3. Is that less than 4? Well, that's 0 minus 3. Is that less than 4? And the answer is yes, absolutely it is. So we know that we have answers to this inequality that lie in this middle section here. The last section we'll try is over here on the far end where we're greater than 7/2. And the values that work there are going to all either work or not. So we're going to select one value over there. I'm going to choose 4. And 4, when we plug it in, would be 2 times 4 squared minus 5 times 4 minus 3. And we want to see if that's less than 4. So we've got 2 times 16, which is 32, minus 20, minus 3. And we want to know if that's less than 4. Well, that actually works out to be, I believe, 9. 32 minus 20 is 12, minus 3 is 9. And that is not less than 4. So we know that these two sections here do not work, but this one in the middle certainly does work. So we know that our answer for x is that x lies between negative 1 and 7/2. Or you can use 3.5 if you so choose, but those are our answers for, or that is where our answer set lies for this inequality. Okay, we've gone through several of the types of problems that you should expect to see on the test. Hopefully with these examples and with the unit review packet that you've been given, you can get well prepared for the test coming up.